some information about decentralized applications, but today we will be talking a little bit more about it. So let's take a look at today's agenda. So as I was telling that I will be introducing you decentralized applications, or in short form, DApps. And then we will continue many practical hands-on from yesterday. So yesterday you did a few programming tasks with Remix IDE, for instance, this hello world, and then uh, storing a number, and then we remove those numbers, and so on. So we will continue our practical hands-on from yesterday. And as said, that smart contracts are the backend of decentralized applications. So basically, we need to learn more about we need to learn more about smart contract development. Okay. And then I will speak about different use cases of blockchain, smart contracts, decentralized apps. So I will explain several of those. And some of them are a little old, but then still they are kind of the base for future use cases, learning about future use cases. So I will share some use cases about blockchain and decentralized apps and so on. Then I will speak about decentralized autonomous organizations. Uh, in short, it is called DAO. And under there, I will talk about DAO types. There are different types of decentralized autonomous organizations. And then, very important topic, I will speak about governance of DAO. In general, this governance of a governance thing can be can be um, can be taken into consideration in any blockchain. It's not just about DAO. So in general, I will speak about blockchain governance, and then I will also speak about DAO governance. And then one of the major challenge of blockchain and DAOs, smart contracts, are these regulatory aspects. And the regulation varies depending on country to country. I'm not very familiar what kind of regulations are there in India, but I am very familiar with the European regulations. So I will speak about European regulations, and then I will talk about what kind of governance strategies uh, you need to do so that you can follow the regulatory guidelines. Okay. So the first thing that I wanted to discuss is decentralized applications. And as said yesterday, we have already covered a little bit of it. So decentralized applications are just like other applications, just like other apps. But the difference is that decentralized applications run on blockchain, where other applications run on centralized systems. So this basically means the backend code means a smart contract runs on blockchain, whereas normal applications backend code runs on centralized system. So, the yesterday the codes, smart contracts code that we were trying, those are the backend codes. You deploy to Ethereum virtual machine, and then you can use some web application to interact with those smart contracts from the front end. And as said, also the dApps can have front end codes and UI in any language. So on the back end side, you have Solidity, for instance, but on the front end side and UI, in the UI, you can use any language. And this is already mentioned that smart contracts are the backend codes. Okay. And then for resources, about about many things, how to run, how to do coding, and so on. This website, ethereum.org slash these developers, everything you will find there. I would like to quickly show you some of the content that you might consider looking at. So I will stop sharing this screen and then I will share a new screen. Just a moment. Just a moment. Yeah. Maybe many of you already know these things or about this resource. But here you will get a lot of detailed information about Ethereum, for instance. So this is Ethereum development documentation. You will find, whatever you want to know about Ethereum. For instance, introduction to Ethereum, intro to Ether. What is Ether? Introduction to dApps, for instance. Let's take a look on the dApps. Yeah, so here you will find the definition of dApp. And then the drawbacks, benefits, and then you will get the link of these tools for creating dApps. And you will find also example dApp, for instance. Okay. Then yesterday we were talking about, for instance, Web 2 and Web 3. So here you will find the comparison between Web 3 and Web 2 and what kind of limitations Web 3 has, for instance, scalability that we discussed, and the cost. And the basic idea, as I was telling, that Web3 applications are run on the decentralized systems. So usually lower performance or
लिंक आया कोई लिंक आया ज्वाइन कर लो कैसे लिंक अभी ग्रुप पे आया
Yeah, maybe you can mute.
अभी चल रहा है क्या कुछ हाँ हाँ
Yeah, please mute.
माइक्रोसॉफ्ट टीम्स पता नहीं क्या
Yeah. Okay. Yeah. So you will find a lot of readings, and then yesterday we also covered about these account types. So as you can see, there are two types of accounts. Yesterday I mentioned externally owned account, which is individual owned by individual, and then contract account. And you will find a lot of details about these accounts, and even account creation. Yeah. So transaction, I think you know what is transaction. This is simple. Blocks we have already covered day before yesterday. What is block? And then we talked about Ethereum virtual machine quite a lot yesterday, and you will find much more information here. I'm just introducing you because if you want to know more, then you know where to go. And then this different implementations, EVM implementations, and then what kind of further reading you could have. And then we talked about opcores yesterday. So once, if you remember, yesterday we were talking that once it is compiled, then it generates the bytecode, which is opcodes. So this is what this type of things it generates, the arithmetic operations. Then this gas and fees, because when you execute something on Ethereum, it consumes gas, and then you need to pay. So that is gas, and then Ether, you pay with Ether. So that is the fees. So it is explaining how gas fees are calculated. Yep. And then yeah, consensus mechanism. I think tomorrow Dr. Devia will teach you different consensus algorithm, especially proof of stake, proof of work, and proof of authority. But you have basic information here as well. And then this Ethereum stack is very important. So Ethereum stack has this Ethereum virtual machine in level 1, which you know, then smart contract in level 2, Ethereum nodes. You also know Ethereum client APIs, and then end user applications. So this is the Ethereum overall Ethereum stack looks like. Then if you look at the smart contract languages, yesterday we talked that, okay, there are two most active languages, Solidity and Viper. And we tried Solidity with this Remix IDE. We tried it yesterday. And then what else? Development networks. Um, it's not that interesting. Yeah, IDE, for instance, yeah, web-based IDE we have. Remix we tried on the web-based, and then it seems Chain IDE is another one I have not tried. But if you are interested, you can give a try. If it is web-based, you don't need to install anything, most likely. Then you have these desktop IDEs. So Remix Desktop is also there if you want to have it in your local machine. And then there are, different plugins and extensions and so on. In terms of programming languages, as you can see, it supports different types of programming languages: Dart, .NET, Go, JavaScript, Python. So it supports different programming languages. Um, and then this concept, this one is very important, this oracles. Oracles here means there's some external data sources. So smart contracts sometimes need to read data from external sources or off-chain data sources. So those are called oracles. So you can read more about oracles here. Yeah. Okay. Um, then yeah, then this website is also very good if you are if you want to set up your environment. So you can just either learn Ethereum development, and it will go to the previous website that I was showing. But then and then here you will find tutorials, next one. And then third one is if you want to do experimenting, then here. But then I think this setup of local environment, this is interesting. If you choose it, then you will find what kind of options do you have. So the idea here is that there are very systematic guidelines. You just need to follow that, and then choose one of the development environment. Okay, so this is just I wanted to show you if you want to um, learn more where to go. Okay, now I will go back to my previous slide. I will share the previous slides now. Just a moment. Where is it? Just a moment, please. Yeah. Okay. So I have shown you the different resources that you can use for Ethereum development, blockchain application development. It's happening. Okay. Yeah, but then I have a task for you. Um, so you just need to continue on the remix environment that I showed yesterday, and then try to write this wallet contract. So your task is to write a wallet contract that can deposit, withdraw, and check balance. So three functions. It can deposit something, some ether or something, some ether definitely. Then it can withdraw, and it can check balance. You can Google, you can take help from Google. It's pretty simple to implement, but it might take still time because if you are new, it will take time. So I do not know if it will take 30 minutes, but maybe 15 minutes, or let's see. So I will now make coffee for myself, and then please go to this remix IDE, and then try to develop it. And then once you are done, write it in the chat or just say it's done. But I will come back in 10 minutes and I will ask you if you are having any problem. And just like before yesterday, uh, even if you cannot solve it, I will send you the code and you can run and test it. But what is important is that you try. You try it, and then I will send you the code, and I will try to even explain the code so that everyone can understand. Okay, then, any question on this task? Okay. If no question, please continue. I will be here in 10 minutes. Then I will ask if you are having any problem. Okay, how are we doing? So Avinab says he's done. But how about others? Okay, you can try. We have time, no problem. You can try. Okay, Abhay also says it's done. Yeah, let's wait few more minutes so that more people are done. Then we can move to the next thing. Okay, so Ashutosh says it's done. Dr. Sudhanshu Kumar Jha also says done. Um, so how about instead of not me sharing the code, of course I can also share. I just want to see how one of your code, and then I will also share mine, just to see if you have done it a little differently. So maybe after 5 minutes, when more people will be done, then one of you just can copy paste the code in the chat. Whoever wants to volunteer, it's fine. Just one of you just share the code, but not yet. Maybe after 5 minutes, when more people will be done. Okay. Also, Mridul says he's done. Keshav done. Thank you. Oh, what is that? Mute. Some chopper sound.
Done, sir.
Okay, good. Very good. Okay, so it seems not many people managed to do it yet. 3, 5, 6, and then 7. Yeah, maybe only 7 people have managed to done it. I managed to do it. So, can any of you? Yeah, okay, more. Alka, thank you. Alka says that. Yeah, yeah. Someone has given the text. Sorry, code. Yes. Um, so those who didn't manage to do it, please use this code and try now. Avinav, thank you. You have provided the code. So what it is doing, so it is initializing the variable with balance 0, and then okay, it deposits the amount. Balance is okay, getting plus, and then if okay, it is checking also if the required balance is there. If not, then it says that balance not available to withdraw. And get balance is just reading the balance. Yes, good. Yeah, please try this code to everyone who didn't manage yet. Please try that, and it should work. I have my own code also. My code is a little bit different. So I have used mapping instead of uh, unsigned integer. So I have address and then unsigned integer variable together. I put that code also in the in chat. Is it? Yeah. Yeah, I have also put my code there. Yeah, but the logic is, as you can see, the logic is same, and the functions are also almost same. Okay, but I request that everyone please try one of these codes to your remix environment and make sure that you understood and your code is working on your environment. Maybe I wait a couple of more minutes. so that you can try. Okay. Uh, so I believe that everyone managed to get it done. Then let's
So
continue.
from your code,
Yeah.
I cannot deposit money. There is no box for deposit.
Oh, really? Okay. Maybe when I then did I copy
एक
it
मिनट
right? Uh, No function. You mean no deposit function is there? You mean that I need
So
to?
there is a deposit function, but not a input value. Input value space is not there.
Oh, okay. Yeah, I need to see. Let me quickly check. Wallet, File Explorer, wallet. Okay, let me new wallet. What is the problem? But did you try the other code? So Ovina or someone gave?
Sir, I gave the other code.
Oh, okay. Okay, so let me compile and then mm, run it, deploy. And I have it here. Oh, it's deposit. Yeah, the amount is not specified, but just a moment. Let me still check. I can ether and then I can choose one ether. Yeah, yeah. Okay, I will show you the thing. Uh, so this code has been written. I do not know what I'm sharing now. Can you now see my remix? Um,
Yes, sir.
yeah. So now I have now. So as you see that there is no deposit box, right? Deposit input. But I managed to still transfer the money. So what I did here, I am transferring from my own wallet. So from here, so I am choosing, let's say 4 Ether from here, and then I will deposit here. So now you see I have now 5 Ether. And if I check balance, I have 5 Ether. So what it is doing, like who is executing the code? I think that it is written in such a way, who is executing the code. So he himself sends the money, deposit the money. So this is why. So from my own account, I'm transferring. This is my own test account, and I'm writing. Let's say again. Let's say I'm writing 5 more Ether. And you see, I have now Ether 94.99, and then I will deposit now, and then I will have 10 Ether. And now from my own account, it's 89.99. And if I check balance, I will have this, 10 Ether now. So this code is a little bit different than the one that you have. Your one is a little more simpler, maybe. This one has a little bit, the logic is different, a little different. Okay.
Yes, sir. Okay.
Yeah. Okay. Thank you. Thank you for pointing it out. Yeah. Okay. Then let's continue. I will now continue to the next agenda of today. Basically, I have more of these tasks, but if we continue doing these tasks one by one, it will be boring. So let's try to do something else for now, and then we will come back to this task 2. I have task 2, I think 3 or 4 tasks I have, but let's not do immediately this task 2. I will now speak about something else, and then we will come back to task 2 once again later. And then I have task 3, task 4, but we will do these later. Let's talk about some use cases. Okay. Yeah. If you go to this Hyperledger website, I will show you the Hyperledger website as well later, and its development tools, what kind of tools it supports, and what kind of things it has. So I'll show you. But anyway, so with the help of Hyperledger, there have been quite many use cases, and these use cases are very classic example use cases. And then the first one use case is about Walmart. So Walmart wanted to monitor its supply chain. So it wanted to monitor the food traceability. Okay, so the food supply chain they wanted to monitor. So the problem was this. The problem I have it is explained there. But the point is that they just wanted to trace the food supply chain to identify where some problems are happening. So what Walmart did, they developed this blockchain-based decentralized food supply chain ecosystem. Okay, and they created the traceability or this blockchain-based system using Hyperledger Fabric, not by Ethereum, but Hyperledger. And then IBM and Walmart developed the proof of concept, and they tested their system in 2 contexts. And one project or one context was about tracing mangoes sold in Walmart's US stores, and the other aimed to trace the pork sold in Chinese stores. So mangoes they wanted to trace in the US, and then pork sold in China. So, and then they showed that this kind of food traceability system really works. And they found that for pork in China, it allowed uploading certificates of authenticity to the blockchain, bringing more trust to a system where that used to be a serious issue. So certificates can also be part of this blockchain. So they uploaded certificates of authenticity to the blockchain. And for mangoes in the US, the time needed to trace their source went from 7 days to 2.2 seconds. So basically, the point is that if all data is there and reliable, then if there are some you need to trace something, it is very fast. You don't need to make phone calls. You do not need to check any documentation. It's just few seconds thing. So that was the Walmart case, very popular Walmart case, where they wanted to increase the traceability of food supply chain. Then later, IBM saw that it is working for Walmart case. So why not to extend it for other foods, other types of foods? And you know that this food ecosystem, is very much interconnected. So, so Walmart wanted to make sure that all the stakeholders in the ecosystem, all the parties in the ecosystem may participate or may be involved. For instance, this IBM Food Trust, what they did, they connected farmers, processors, distributors, retailers to create visibility and accountability in the food supply chain. So all supply chain participants were involved. And by that, they made a complete history and location of individual food items, along with certifications, for instance, temperature data even. If you have, let's say, if the farmer is harvesting in some environment and you have IoT tools, IoTs, and the temperature data is recorded and sent to the blockchain. So as you can see that you in a problem you can connect all these participants, all these stakeholders, and not only that, you can upload the certifications and even different types of data like weather conditions, temperature data, everything. For instance, you can think of that, okay, some companies transfer food from one city to another, and they need to maintain certain temperature to make sure that the food uh, is not rotten. And how to verify that during the transport the temperature was accurate, was correctly measured or correctly documented. So if there is an automated system and the temperature is continuously monitored, and then temperature data is sent to the blockchain, and later anyone can verify that, okay, when the food went from one city to another, and during the transportation time, whole time, the temperature, good temperature was maintained. So, so anyway, the whole idea of IBM Food Trust is like this. So it's connecting all the supply chain members, supply chain participants, and also automatically record different data, and also uploads certificates to increase the trust among consumers. So that was the IBM Food Trust example. And then there is this another one called Scan Trust. And this is about coffee. So this Scan Trust wanted to enhance its offering in supply chain traceability and help their client, Cambio Coffee, bring more transparency to their ethical trade business. So here you can see the idea is similar, but instead of other foods, they wanted to trace or increase the transparency of coffee. So they developed this blockchain with Hyperledger Sawtooth. So another ledger they used and then to achieve traceability function for their existing application. So what the system really did is that it provided transparency and traceability